Hi student, we see again there's a lesson 11.3. Now we start, this topic is talking about the mass and also the inertia. Okay, let's see what is that. Okay, first one we need to introduce what means of inertia. Inertia, the definition is a quantity of matter in an object. So another one is a SI unit. SI unit for the mass should be the kilograms, kg. Okay, how we go to measure the mass? We're using the digital scale. Another one should be the analog scale. Okay, let's see the example. Okay, this one we call digital. So later they will show the readings. Okay, another one is the analog. So this one analog, that means you need to count by yourself. They show which one reading, then you need to read by yourself. Okay, then after that we show another physical quantities. Okay, another physical quantity, there's a inertia. Inertia is a one thing that means we cannot see. We also cannot count. We also don't have any unit. But this one, inertia, is one of the feeling. That means you can see it in your daily life. You also can feel it. Okay, let's see what is the inertia. Inertia is a natural tendency of an object to resist change in the original state. Means they got one of the things in the object, example for the human also got, they do want to change the situation. So example, the situation now is a rest. If don't have any forces, that means the object will continue rest. Okay, unless you got something to push the object to move, finally the object to move. So you can see the example here. Okay, when starting the bowling pin, there's a stationary. Then finally when the just bowling hit the pin, you find it the pin. Okay, have to move together. So this one we call it the inertia. If the inertia is higher, that means you cannot stop. But now the bowling pin, they move together, is it? So that means the inertia for the bowling pin may be less. Okay, another one is in motion. Okay, maybe you are moving, but you don't want to stop. Okay, now the force will make you to stop. You see what happened? Okay, this one is a diagram. Okay, a person, they drive the car, suddenly they hit the concrete. Okay, so the car want to stop. But the driver in the car, they cannot stop immediately. They want to continue to move. So finally, they will thrown forward. So this one we call inertia of the driver. Okay, so from here, the inertia, they cannot be measured. And also, they don't have the value and also the unit. Okay, let's see one of the citation about the inertia. Okay, they say original state is a rest. So that means we see the coin. The coin is on the cardboard. Okay, original state, there's a rest. Okay, now we see the citation. Okay, you find it, they jerk the card. Okay, when they jerk faster, the coin never move together with the card. They still drop inside the glass. So this one is a citation how to explain by using the inertia. Okay, let me see how to explain. Okay, so when starting the coin on the cardboard, okay, when you just move the cardboard faster away, so you find it, the coin is not together move with the cardboard. They drop inside the glass because of the gravitational force to put it. Okay, if I move slowly for the cardboard, you find it, the coin will drop or not? Okay, I think there's a definitely they do not drop because they will move together with the paper. So this one citation means the inertia of the coin, they want to maintain the original state. The original state for the coin is what? There's a rest. So that means they want to maintain, they don't want to move together with the cardboard. Finally, they drop inside the glass. So if the situation you pull slowly, actually the coin got enough time to change the situation. Just now it's not enough time because you're too fast already. If you move slowly, you find the coin. They got enough time. After that, they will move together with the cardboard so they do not drop inside the glass. Okay, now we're going to see the explanation. Okay, the observation, we find it, the cardboard is pulled away. Okay, quickly, yeah? So the coin will drop straight into the glass. Okay, let's see the explanation. Okay, the inertia of the coin. Okay, of the coin and not of the cardboard, because cardboard you go to move it. The coin you never touch. So we're talking about the inertia of the coin. They want to maintain the original state. What is the original state? The original state is stationary position. Okay, even when the cardboard is withdrawn. So you find it, they will fall into the glass due to gravitational force. So this one is one of the situation of inertia when the object is rest. Okay, then we go and see the next one situation. Okay, this one is when the object is in motion. Okay, we see what happened. Okay, the car start to move. So can you see the passenger? They launch backward. Okay, they move to the backwards. So the question will ask why? Why the passenger will be like this? Okay, let's see the explanation. Okay, when the bus just move, the passenger will move backward to maintain his original state. Okay, original state for the passenger when starting is rest because the bus not yet to start. When the bus start to move, that means the passenger inertia. They cannot exactly so fast to change the situation. They want to maintain to rest. So that means the body will move backwards. Okay, now we see the situation. Okay, the bus stop. Can you see the passenger? They move forward. Okay, this one also is the inertia of the passenger. Means the bus already start to move, then the passenger also move together. But the bus suddenly to stop it. Okay, but the passenger body cannot immediately to start because of the inertia. Finally, they keep moving. Keep the original state, there's a moving. So they will move forward. Okay, now we go and see the explanation. When the bus stops suddenly, then the body of the passenger, they want to maintain. So that's why it's forward motion. So finally, you find it, the passenger will thrown forward. So this one is an example diagram for the state in a motion. So this one diagram is the car suddenly accelerate. So the passenger, they move backwards. So this one is normally in the car when the passenger is standing. So suddenly the car start to move, all passenger will move backward. And suddenly the car, they will immediately brake. So you see all the passenger, they will launch forward. Okay, let's see the explanation for this one situation. Okay, inertia of the passengers, they want to maintain the original state. So that is either rest or either motion. Okay, because of the inertia. So this one situation, we find it. There's some go forward, some situation will go backwards. Okay, now we're going to see the explanation of the inertia by using the Newton's first law of the motion. So from here, Newton's first law of the motion of an object, they're talking about remain at the rest or they move uniformly velocity unless they got external force acting to the object. Suppose Newton of the first law, we can relate it with the inertia. The meaning should be the same. That means the object, they want to maintain the original state. Either is rest, either is moving. Okay, unless you got the external force exert to the object. So the object need to change the situation. Okay, let's see another example for inertia. Okay, so now the cloud, they want to pull the tablecloth. Okay, above the table, we got valve, we got plate, is it? So now, if the cloud, they want to make all the object on the table remain on the table, what they need to do? They must pull the tablecloth faster. Is it? Because the valve and also the plate, they got inertia. So if the situation suddenly happen, that means these two things, the inertia cannot change immediately. They still want to maintain the original state. The original state is stationary. Okay, so we see the result. So they pull faster, you find it, both objects still on the table. Never follow the tablecloth, move together. Okay, after we talking about the Newton's first law, we go in relationship between the two physical quantity, what we learned just now. There's a mass and also inertia. Okay, now we go and check. This one is an empty trolley. This one is a full trolley. So empty trolley, the mass become less. This one should be the larger. So when you go to push, okay, which one easier to move? Sure, it's a empty one. Easier to move means they're faster to change the original state. But this one, larger mass one, they take some time to move. So that means I can conclude the larger the mass of the object, the larger the inertia of the object. So from here, this one small mass, understood, the answer is smaller inertia. This one is larger mass, means the inertia must be larger. Both mass and also the inertia is a directly proportional. Okay, this one is a one of the experiment. They want to find the relationship between the mass and inertia by using inertia balance. So this one apparatus we call it inertia balance. That means they put the rod. Okay, this one is a rod. Put one rod, after that they let it to oscillate. Then finally they put 3 rods, then let it to oscillate. Sure, the more rod, that means the mass increasing, your oscillate must take some time. So you can see example diagram here. Differentiate the time for the swing to oscillate. You can see the thin people, when they sit on this part, when they just go to swing it, you find it easy to swing, is it? But this one, it will take some time to swing it. You also need to put more effort, let it to swing. So that means the inertia of the bigger size, or you say this one bigger mass, higher compared to the smallest mass. Okay, so from here we got one of the experiment. They want to find relationship between the mass and also the inertia. So from here, the hypothesis, the larger the mass and also the larger the inertia. Inertia we cannot control, so we cannot make it as a manipulate variable. We take the mass is a manipulate variable. So from here, variable, manipulate variable, we're using mass of the plasticine. Responding, inertia we cannot measure, so we cannot using inertia to calculation. So we're using the period of oscillation to represent the inertia. Period of oscillation means we take the time taken when the hexoblade to oscillate. We want to measure the time taken when they just oscillate. Okay, constant variable you can say about the length of oscillation for the hexoblade. You also can say about the shape of the plasticine. Okay, now material we need to using is a plasticine, G-clamp, hexoblade, stopwatch, and also electronic scale. Okay, let's see the diagram. Okay, so this one is a diagram you need to draw when you write the report. So we got G-clamp, after that the hexoblade. So at the end of the hexoblade we put the plasticine, then you need to oscillate. Okay, let's see the first one procedure. You need to set up. So all the thing you say just set up as a figure, so you no need to explain more already. Okay, number 2, you tightly the clamp the hexoblade horizontally onto the leg of the table using the G-clamp. Okay, number 3, the important is 30 gram. So you must tell when starting you using the plasticine is how many gram. That one is a manipulated variable, the first one. So you just mention the 30 gram, you stick on the bit of the plasticine with the mass 30 gram on the end of the hexoblade. Okay, number 4, you must say you oscillate. So you slightly to pull the end of the hexoblade with the plasticine and release it so that it oscillate horizontally. Okay, after that you want to oscillate how many times, so you need to mention. So you need to take the time taken for 10 complete oscillation. Okay, this one is a responding marks. You say you let it to oscillate 10 complete oscillation. Then you're using the stopwatch to measure and also record. Okay, now I want to show you the experiment, how we go to procedure it. After that we get the result. Okay, so we start. Okay, we clamp hexoblade. Okay, put the plasticine 30 gram. Okay, let it to oscillate for 10 complete oscillation. Then we drop down. Okay, when I using 30 gram 10 complete oscillation, there's a 4.3 second. So we repeated. Okay, now we repeated by using the 40 gram. Okay, also same. You oscillate for 10 times. After that, we drop down again. 40 gram. After that, the time taken is a 4.8. Okay, so we continue again for the 50 gram. Okay, when I just put 50 gram, they oscillate for 10. Then we all measure the time. 5.4. So that means until 50 gram we find it. The time taken keep longer when the mass increasing. Okay, we continue for 60. Okay, oscillate for 10 times. Then we drop down again 60 gram. The time taken is 5.8. Okay, the last one we repeated. So that means total we do 5 sets. Okay, now it's a 70. 70 you put, also the same, oscillate for 10 times, then we drop down. Okay, this one is an overall reading. You drop down from the table. So you must have the mass. Then you must time taken for 10 complete oscillation. This one is the answer. So the time taken keep increasing. So after that, you must find what is a period. Period means one complete oscillation. This one is 10 times. I just want one time only. So what you need to do, you take the 4.3 over the 10. So you put 0 point something, okay, in the table. So this one is a result. Okay, now 6. Just now the procedure we still not yet finished because we just say oscillate only. Okay, 6 you need to determine the period T. Okay, you need to count the period for one complete oscillation. So just now the table show already how to count. There's a time taken over 10. So you get the answer 0 point something. So we need to repeat it. After you finish all the one set, so you need to repeat it 3 to 6 using the plasticine with the different masses. So here got 4 different masses. That one is a minimum set. You can set 5 set, 6 set, 7 also can, but cannot less than 4. Okay, so this one is a result. The result from just now table. Okay, so what conclusion I can make it? So the conclusion normally is follow the hypothesis. So the hypothesis, they say when the mass increasing, the inertia also increase. So from here, the larger the mass of the object, the larger the inertia of the object. Finally, you need to add one more sentence. The hypothesis is accepted. Okay, so this one is a full report for the experiment 11.3. Okay, then the experiment 11.3, they got question. Okay, let's see the question. The first one, they find the relationship between the mass and also the period. So we also find it when the mass increasing, the period oscillation also increase. So we just answer, larger the mass, longer the oscillation time. Second relationship, there's an inertia and also mass. So normally we just mention the mass first because the mass is a manipulate variable. So the larger the mass, the larger the inertia of an object. Okay, C. Is the period of oscillation of the hexablade affected by the gravitational force? Okay, from this one experiment, we never using any gravity. We just calculate the mass only, is it? So there's a not related about the gravity. So from here, my answer is no. Okay, then we go to the next one. Okay, effect of the inertia in the daily life. Okay, we got positive effect. You see what's the positive effect? Okay, the first one is the hammer. Okay, this causes the hammer head to continue on its downwards motion. So when you just knock, you knock the holder of the hammer, okay, suddenly you stop already. Suddenly you stop, but the head of the hammer, they still continue to move because they cannot stop immediately. Okay, because of the inertia. So they say they will continue on its downwards motion when the handle has been stopped. So that the top of the handle is locked deeper into the hammerhead. Finally, you find it the hammerhead, they will go deeper, go to the handle. If you reverse go to hit the table, finally when you take out the handle, you find the head already fall down. So normally you want to make the head and also the handle become tightly, then you need to do this one situation. So another positive effect we can see here. Okay, rotate the umbrella. Okay, let's see here. The drop of water on the surface of the umbrella, they will move simultaneously as the umbrella is rotated. When you start to rotate, sure the droplets move together, is it? But when the umbrella you stop to rotate, what happened? You can see the droplets also will drop. They cannot stop immediately, is it? So from here they say there's an inertia of the drop of the water. They will continue to maintain its position. Okay, this one situation just like the chili sauce. When you want to shake the chili sauce to come out, you go to shake your hand, is it? Okay, when you just shake there until you stop. Okay, the chili sauce, is it immediately to stop? No, they continue to come out. So that one we call it there's an inertia of the sauce They cannot stop immediately, although your hand stop to shake the chili sauce bottle, but they still continue to move. Okay, they move, flow out. So this one is a positive for the effect by using the inertia. So when you got positive, we sure got negative. Okay, let's see the negative. Okay, the first negative, there's a seatbelt. Okay, when the car stop suddenly, sure, the driver cannot immediately to stop, is it? So the driver and also passenger in the car, they will thrown forward. So because of their inertia. So now what they need to help, they're using the seat belt. Okay, to seat belt to hold the driver back to the original position. So prevent them from being thrown forward and also hurting themselves. Beside the seat belt, we're also using the airbag. Okay, prevent the passenger or you say the driver that hit to the touchboard or you say steering. Okay, this one is another one effect. During landing for the aeroplane, they cannot stop immediately, is it? Because of the larger mass. So normally, they will moving for the long distance. So they say they cannot stop within a short distance due to the inertia. Therefore, they will build a long runway. So they must slow down. They cannot immediately to slow. They must slowly until to stop. So the runway must be the longer. So you find it, the airport must be the bigger area to build it. So, okay, to let the aeroplane to landing, and also they want to lift up. They also need to move for long distance, then can lift up. So this one is one of the negative effect for the inertia. Okay, so the last one should be your exercise. There's a formative practice 11.4. So you need to answer this question inside your exercise book. That's from your textbook, page 249. So from here, our lesson just a short lesson only. Then we until here only. So that means the chapter 11, there's a finish. So the coming soon would be the chapter 12. That's the last one for your topics. So thank you for your watching.